distinguishing features between what we call Eastern science and what we call Western or modern science. And the distinguishing aspect of Western science is through designed experiments. You come up with a theory, a proposition, but that, by the definition of modern science, it has to be falsifiable. If the principle, the theory, is not falsifiable, if one cannot provide an avenue through which one can test it, then it is not rigorous. J.C. Bose probably was the very first scientist in the Indian subcontinent to adopt that philosophy. So that's why he is called the doyen of modern science in India. He was initially educated in a vernacular village school, and he was taken care of by an ex-convict. His father was a deputy magistrate, so he was in charge of the local discipline and law and order. And there was a convict, ex-convict, whom he tried to rehabilitate, and he left Jagdish Bose in his charge. So he would take Jagdish Bose to his school, teach him all kinds of village games, teach him how to swim, and introduce him essentially to nature. And it was this lesson which remained with J.C. Bose and modeled his approach to science to a large extent. He moved to Calcutta in 1870s and entered St. Xavier's College in 1870 and got his BA degree from this college. And it is in this college that he met a Belgian Jesuit teacher, Father Lafont, who used to teach them physical sciences. And it was Father Lafont who introduced J.C. Bose to demonstrations in physics lectures. So in his college, rather than giving rules of physics, okay, and write them out on the blackboard, he used to demonstrate principles through examples and hands-on examples, which was J.C. Bose's motto all his teaching. He married in 1887, Lady Ovola, who in her own right was a very accomplished and dedicated person. She was the moving force behind Brahma Balika Vidyalaya of Kolkata. After his bachelor's, as was the wont in those days, even though Bhagwan Chandra Das's father wasn't really very affluent, and he had also passed away, leaving a large amount of debt to J.C. Bose. J.C. Bose went to England to study medicine, but the rigors of study of medicine didn't suit him, primarily because during his early youth, he had contracted Kala-Azar during his trips to Assam. And in the cold weather of England, that cleared up. And his mentors suggested that you won't be able to withstand the rigor of medical education. So why don't you shift to natural sciences? So he shifted to Christ's College in Cambridge. And in Christ's College, he studied physics, botany, and chemistry. So he got his tripos in 1884, and his later directions in studies and research were essentially modeled by the people he met there. J.C. Bose returned to Calcutta after his tripos. After a bit of uncertainty, he finally managed to get a job, a teaching job as professor of physics at Presidential College. He wanted to show that the analogy between electric radiation and light, which is the basic tenet of Maxwell's electromagnetic theory, it could be rendered more complete if the class of substances which polarize light were also found to polarize the electric ray by refrigerants. Right? Now, the hindrance was that if you have a 66 centimeter long wave, to reflect it, to refract it, to polarize it, you really need crystals and mirrors the size of this room. Because otherwise there would be such huge distortion that you won't be able to conclude anything. And this is where the marvelous thing that J.C. Bose did. He succeeded in reducing the wavelength to about 5 millimeters, which we call microwaves today. And he performed his experiments with moderate size, manageable crystals. And the interesting thing is that this was done at a time when the idea of waveguides was totally non-existent. What was interesting is that he found a new detector, the so-called spiral spring coherer, which holds sets of springs held together side by side under pressure that can be varied. And so the detection takes place at the many points of contact between the coils of the spring. This is a diagram of this detector. He also showed that there are various kinds of polarizations which polarize both electromagnetic, both light and electromagnetic fields. For example, one of this is a cut-off metal plate grating, and this is consisting of a book, the Bradshaw's Railway Timetable, and interleaved with foils of tin. So with this, he could use as a polarizer. And George Barnard Shaw humorously said that, well, J.C. Bose is probably the only person who can shine light through the red shell. Twisted jute polarizers. Notice that all of these ingredients, all of these parts of the apparatus were made from indigenous ingredients and made in-house. And that has actually been J.C. Bose's hallmark all through. Lord Kelvin, Lord Rayleigh, all of them were there at the Lawrence Royal Institution, and they congratulated J.C. Bose because this was effectively first demonstration of propagation of signals without any wires. Marconi was in the audience in London when J.C. Bose gave his lecture. And J.C. Bose wrote to Rabindranath in a letter that there was tremendous melee after my talk. There were several people who wanted to take out patents for this, but I did not want to agree to that. And in that melee, somehow my handwritten notes disappeared. Somebody pinched them. And what happened was that in 2 years' time, Marconi repeated his experiment and achieved success by using the detector which was fashioned after the phone antenna that I showed you. And when people asked Marconi that how did you come to the design of this horn antenna, he said that Righi had suggested it. Righi, when he was asked, denied. So this controversy was never really settled. Marconi got the Nobel Prize. J.C. Bose was not mentioned in any of these inventions. When somebody asked J.C. Bose whether he felt cheated by not having got the Nobel Prize for his discovery, J.C. Bose's answer was that doesn't matter who gets the credit for it as long as the work gets done. But I think Sister Nivedita, Sarah Chapman Bull, and Vivekananda felt piqued at this. So they insisted that J.C. Bose file a patent. And he filed a patent in 1899, the first US patent from Asia. And it said detector for electrical disturbances. And this had one ingredient which is very significant, and that is the detector material in this was lead sulfide or galena. And J.C. Bose did its characteristic, analyzed its characteristic, and published included them in his writings. And this was essentially the very first example of a semiconductor. Anyway, this patent was granted in 2004, but J.C. Bose never renewed it. And historically, the person who paid for this filing fee was Sarah Chapman Bull. And J.C. Bose wrote a check to Sarah Chapman Bull for the filing fee of £80, which Sarah Japan will endorse to Lady Obola, and this was never encashed. We found this check in J.C. Bose's archives. In the year 2006 or 2007, when we were celebrating the Foundation Day of Bose Institute, on which day the Institute has an open house and visitors are welcome to visit the archival museum. Somebody came and told me that there is a foreigner who's visiting the museum, spending a lot of time there, and then he has written something in the visitors book. I was busy with the speaker of the Foundation Day that day, so I did not have a chance to go and read him or find out who he was. So later on, when I looked at this visitor's book, I saw that the visitor had written that having been to this museum, I realized that Sir J.C. Bose did the experiments leading to wireless transmission of signals 2 years before my grandfather, and signed Francesco Parese Marconi. It's still a marvel that the accuracy of many of these systems continue unsurpassed even today. Many of the responses that he obtained were at the level of single cell responses. Of course, his interpretation did not appeal to people, so they kept saying that this is not genuine science, this is Eastern mumbo jumbo. The journey from physics to biology. To sum up J.C. Bose's life's contribution, and Sir Neville's quotation was repeated there, and they said that if his electromagnetic research was 60 years ahead of their times, his plant biological research was a century ahead of his times. Because many of the measurements that he had predicted are now being repeated, and there is actually a very vibrant field called consciousness in plant.
From the temple of science in the west, far across the Indus, oh, my friend, you have brought the garland of victory, decorated the humbled head of the poor mother. Today, the mother has sent blessings in words of tears of this unknown poet. Amidst the great scholars of the West, brother, these words will reach only your ears.